Well, now, one thing, you have a theory about the moon, and we expect to be able to get observable facts about the moon fairly soon. What is your theory?
Well, it is by now rather more than a theory. 10 or 11 years ago, I stated to various scientists that the moon is not a piece of rock, but it is a plasma phenomenon, cosmic plasma, and that this fact will eventually be confirmed. I made certain predictions which were already confirmed in 1958, and the situation now is coming close to a complete confirmation.
What will be the result if you're proved to be correct in your theories?
The result will be profound and decisive, because it will give proof that a complete reinvestigation of the laws of nature is necessary.
In a recent space news, Thunderblog contributor Jimmy Micketts offered a thought-provoking analysis of an audible phenomenon that has puzzled scientists and laypersons alike for decades: the mysterious so-called hum. As we've described in many episodes, anecdotal accounts dating back centuries describe puzzling sounds associated with electromagnetic phenomena, such as the Northern Lights. But what about the ability of sound to produce in matter phenomena that may be fundamentally electrical? So-called sonoluminescence, or the emission of light flashes when sound waves passing through liquid burst bubbles of gas, is a source of both puzzlement and growing scientific interest. An article in the journal Nature entitled "Collapsing Bubbles Have Hot Plasma Core" describes detailed measurements of the phenomenon. It states, "They call it a star in a jar. When sound waves crush bubbles of gas in liquid, energy is released in a dramatic burst of heat and light. Now the first detailed measurements of the phenomenon have shown that the molecules in the gas really do create a pinpoint of plasma, the energetic soup of ions and electrons found in every star." The research raises hopes that the effect, called sonoluminescence, might one day be used as an almost limitless source of energy. In this episode, Jimmy Micketts explores the possible importance of sonoluminescence in our electric universe.
What if sound didn't only flow through matter but could produce unexpected phenomena like light? Research in sound has revealed the capacity of sound to influence matter in a way that produces light. The phenomenon of sonoluminescence is one example of this relationship. Sonoluminescence occurs when high-frequency sound vibrates tiny gas bubbles to reach star-like temperatures and emit flashes of light. The mechanism of sonoluminescence is not fully understood, but its occurrence is well documented. As SL researchers probe deeper into the phenomenon, they have found that current fluid dynamics equations do not explain why it happens. Sonoluminescence is a natural phenomenon as well, and marine biologists observe some species of shrimp using it as an attack against other creatures. It is the bridge between sound and light and can offer a deeper understanding of nature's laws. In a study at UCLA called Sonoluminescence: How Bubbles Turn Sound into Light, scientists S.J. Putterman and K.R. Wenninger explore the mathematics and phenomenology of sonoluminescence. It is known that this phenomenon is caused by the rapid expansion and contraction of a bubble. This is known because the broadband UV light emitted appears at a frequency, though not continuously. Think of a strobe light as an analogy where flashes of light last only picoseconds, which is a trillionth of a second. According to Professor Putterman, the phenomenon of sonoluminescence can heat bubbles up to tens of thousands of degrees. The surface of these bubbles burn at 20,000 Kelvin, which is 35,000 degrees Fahrenheit, and they look like little stars. Quote, "Sonoluminescence, the transduction of sound into light, is a phenomenon that pushes fluid dynamics beyond its limit. Sonoluminescence can be repeatedly produced in a controlled laboratory environment. Some of the key requirements are degassed water, a noble gas mixture bubble, and a source of high-frequency sound. Typically, the sound is produced by a piezoelectric element. The scale of the experiment is typically small. Only about a cupful of water is necessary, and the size of the bubble is typically only microns in size. It should be obvious why the phenomenon has gotten the nickname of star in a jar. The small cavitating bubble takes on the appearance of a small star. Conventional fluid dynamic equations do not account for sonoluminescence entirely. Specifically, some research have applied Raleigh's equations to the bubble collapse, but this, quote, violates its domain of applicability according to Putterman and Wenninger. At present, these equations do not adequately explain sonoluminescence for a variety of reasons. Some researchers believe that during sonoluminescence, bubbles have an inner core of plasma. In a study published in peer-reviewed journal Nature, entitled Plasma Formation and Temperature Measurement During Single Bubble Cavitation, researchers state that, quote, emitting species must originate from collisions with high-energy electrons, ions, or particles from a hot plasma core. Other research supports the hypothesis that sonoluminescence bubbles have a hot plasma core. According to another recent publication called Evidence for a Plasma Core During Multi-Bubble Sonoluminescence in Sulfuric Acid, the observation of molecular and atomic ions is the first experimental demonstration of an inner ionized plasma core during single bubble cavitation. Thus, current research suggests that the core of the sonoluminescence bubbles may be plasma, the fourth fundamental state of matter. Perhaps this is the reason why fluid dynamic equations do not match the phenomenon. Researchers discovered that during sonoluminescence, a bubble rapidly expands, then contracts in cavitation. Looking deeper into this, researchers have found that the bubble does not operate within some conventional chemical laws. One of these is the fact that, as the bubble collapses, it rebounds because of van der Waals forces. Sonoluminescence appears to emit the most light with noble gases or noble gas mixtures. An incredible example of sonoluminescence is the stun action of both the pistol and mantis shrimp. These predatory shrimp knock out their prey by loading their claws with tension and releasing it suddenly. In the laboratory form of sonoluminescence, this extreme cavitation produces the same light and extreme surface temperatures. However, this light is not visible to the naked eye as in the laboratory experiment. An article published in Nature regarding the topic, called, quote, Snapping Shrimp Make Flashing Bubbles. Not surprisingly, researchers first looked at fluid dynamics to reach an explanation for sonoluminescence but found it lacking. Could plasma physics be the road by which an explanation will arrive?
North, we know that this is north, we tested it before, that when we put it to proximity of plasma, it shows twist to the right. It means it is in accordance with the theory or the opinion. Now, when we put south side, it should twist the opposite way, as it does. Put it inside, it should spin to the left, which it does. We try to modulate it so that it will go slowly.
It's a little hard to see because of the frame rate of the camera, but yeah. I can testify that it is spinning to the left.
So it means when we turn it the opposite way, we put southward, it should rotate to the right.
Yeah, that's very clear. Yeah, very clear rotating to the right.
So we have quite high spin of plasma.
Dating back decades, various experimentalists have replicated through electrical discharges different types of craters, from those indistinguishable from impact craters to anomalous craters that continue to puzzle planetary scientists. In some instances, an electrical discharge may be the only process capable of producing all of the features of certain craters. In any case, new scientific data will continue to make it more clear that cratering is not the result of periodic impacts from space over eons of time. Electrical cratering is just one of many new pathways of discovery waiting to be explored in our electric universe.